हरिः कर्ता।
Now let's jump into the another module of Matplotlib or Intuitive Plots for You course, that is unstructured coordinates. So here we'll be drawing the complex and complicated 3D structures and 3D uh, graphs and plots. So sometimes we collect data z at coordinates x comma y and want to visualize as a contour instead of gridding the data and then using contour. We can use a triangulation algorithm and fill the triangles. So that's what we are going to do here. So we will begin with the tricontour of x comma y comma z. So that would be our first plot we'll be looking here. So what is this? So which function which method of matplotlib we are going to use here? So the tricontour method or function in pyplot module of matplotlib library is used to draw contours on an unstructured triangular grid. So the syntax, it looks like that, which you can see on the screen. It consists of a different arguments. Out of that, minimum, the bare minimum arguments that are required are x comma y. So what are x comma y? X comma y, these parameters are the x and y coordinates of the data which is to be plot, and after that you will have triangulation argument. So this parameter is an matplotlib dot a triangulation object. Then we have capital Z or Z. This parameter is the array of values to contour, so one per point in the triangulation. Then we'll have a lot of keyword arguments. So the this parameter is text properties that is used to control the appearance of the labels. So let's look into one of the simple example. Let's begin with the simple example for the tricontour. So for that, let's get into our Jupyter dashboard and click on new Python 3 kernel. Then name it as unstructured coordinates. Yeah. Yes. Now let's get into the action. So as usual, this is a new one. It's a new notebook editor. So we have to import. So import matplotlib dot pyplot as plt. Then import, obviously we need to make arrays. So import numpy as np. So both required libraries were imported. One as an alias with plt, another with an alias of np. So now, as usual, we'll name our grid and then we'll make required data and we will create our triangular contour or a tricontour. So plt dot style dot use method. Inside that, I'm gonna say mpl underscore gallery underscore no grid. Yeah. So let's begin. Let's make data. Let's make data So let's begin with the random dot seed of 1. Then the first one, x-axis, the data for x-axis. So the variable name is x array. So x array is equals to np dot random dot uniform methods. Obviously I'll take from -3 to 3, 3 to 3, and 100, 256 fractions. I'm gonna go with 256, and I'll do the same for the y. I'll go with 200, 256. So let me change this to y array so that we can reference later. So rest remains same, and z is equals to 1 minus x divided by 2 plus x to the power 5 plus y to the power 3 and multiplied by np dot exponentiation of minus x to the power 2 minus y to the power 2. That's it. Our z is also ready. So x, y, z, 3 arguments or 3 data arrays are ready. So now let me make it levels. Levels is equals to np dot linspace method, and then z dot min 2, z dot max, and make it into 7. Make it into 7 fractions. So if you just wanna cross check, so what are they? Okay, what's the issue? Let me is the issue with style? Well, it is not valid package. Okay, so it's saying mp grid. Okay, let me take, yeah, that's not a valid so there is something wrong with our mpl gallery. No grid is not a valid package style. So I'm gonna check the valid package style. So path of the style file, or maybe library style file name, there is something issue. Let me look into that. What is it? Okay, so this is what the issue. So mpl, and let me check one more time. plt dot style dot use and underscore mpl gallery, and it's no grid. Okay, it's no grid. It's not no grid, it's no grid. Yeah, that's okay. Sometimes typos. So now let's cross check the values. Arrays, you just I just want to see our arrays. Okay, this is what is our x, and this is what is our y, and let's find z. How does it look? Okay, this is what is our z. You can see that. Now I'm gonna look into the levels. Of course you need to get the 7 levels, and you see that 3, 4, 5, 6, 7. You got the 7. Yeah, that's what is our data. That's how they look. So now it's time to plot. Now it's time to plot tricontour. Tricontour. So let me check fig ax is equals to plt dot subplots, and okay, let me check some something wrong with indentation. Yeah. So let me execute as your subplot is ready. So now let me refer respective arrays to the respective axis. Okay, let me do that. So ax dot, I'll use a plot of x comma y comma and its wo and marker size markdown came, sorry, marker size is equals to, let's give 2, then color is equals to light light gray. That's it, and here it is. The first one is done. So x and y were plotted with a circle shape, and the size is 2. Let me make it 4. Yeah, it's slightly bigger. I'm gonna go with 2.5. Yeah, this is fine. So light gray color, it's absolutely fine with me. So I'll go with the light gray colors. So x and y are marked. X and y are marked. So now what I'm gonna do, I'm gonna draw a tricontour. Tricontour. So to draw that, ax dot, let me take tricontour object method, and x comma y comma z. Uh, then we have levels. So levels is equals to levels. That's what is the variable that we are using. So and execute, and here is that. Absolutely brilliant. So that's how it looks. You see that? Try contour. So let me set the limits. So ax dot set. So x limit minus 3 comma 3 comma y limit minus 3 comma 3. That's more than enough. Now let me go for the plt dot show method and execute, and all done, all set. That's it. It starts with the, because we said minus 3 to 3 here, and here minus 3 to 3 here on x-axis and then y-axis, and here is your complete piece of code. Okay. Yeah, it looks good. Clear? So that's how we draw tricontours.